We will be using your book and a graphing calculator, but for right now, and part of the day, you'll need scratch paper. So take a minute and do these 3 problems, if you would. Raise your hand if you're done with all 3. None. Okay. Oh, 1. Keep working. I'm going to start doing mine up here. this spell work. If you're not done, it's okay. I'm going to talk about it. It's a big part of what we're doing today and tomorrow. This is called binomial expansion. Binomial, because there are two terms and we're expanding it. So we know the first one here in red, a plus b times a plus b. So we just distribute it out and combine like terms. Hopefully what you did when you did a cubed b is you didn't start over at a plus b, a plus b, a plus b, right? We didn't start over, did we? We knew that we already multiplied it twice and got this. So that's why I rewrote that. And then I just multiplied it by another multiple of a plus b. When I get to number 3, which I didn't show all my work for, I've already got 3 of them multiplied together, and that's this. So I need to multiply all of that times a plus b. If you didn't get all the way through to the third one, that's okay. Hopefully you got through the first 2. Did most of us get the first 2 done? Okay. What is this called? Binomial expansion, a big part of today and tomorrow's lesson. By the end of today's lesson, you will be able to do something like this. A plus b to the 7th, and it won't take you forever. And you won't have to have a plus b to the 6th to get a plus b to the 7th. There's some preliminary work we're going to do in our book, and once we get through a little bit of content, you will be able to do this or some other binomial like 3a squared plus 4b to the 12th. You will be able to do that without doing the long way, which is what we just did in bell work. We don't want you doing it the long way if you're going to be doing to the 12th power. Are there any patterns that you notice in just the first 3 that we did? Look at the number of terms. Tell me if you notice something there. Very good. The degree plus 1. That's the correct word I wanted you to say. This is to the 2nd power, and there are 3 terms. To the 3rd power, 1, 2, 3, 4. So it's the degree plus 1 more. How many terms you will have. Anything you notice about the first term? There's something there, right? We notice, go ahead. Yeah, each one, a squared, a cubed, a to the 4th. Notice your last term, b squared, b cubed, b to the 4th. So maybe if I was doing this one, maybe my first term would be a to the 7th, and my last term might be b to the 7th. And everything in between is going to be a little bit different. Notice here I have 3 A's, 2 A's, 1 A, 0 A's. Here I have 4 A's, 3, 2, 1, 0. What about the B's? The B exponents that go the other direction. B to the 3rd, B to the 2nd, B to the 1st, B to the 0, which we don't write. Because anything to the 0 power is 1. But it could be written as b to the 0. Same thing here. B to the 4th, b to the 3rd, b to the 2nd, b to the 1st, b to the 0. So those patterns will help you come up with the long one. And I'll teach you how to do the in-between and the numbers part. So for that, go ahead and open your book to page 255. It's going to seem like it doesn't relate to this at all. And you'll see once we get there how it does relate. Title is Pascal's Triangle. He's a pretty smart guy, Pascal. You learn about his triangle. His triangle will help you figure this out. Don't spoil anything. What?
I was going to ask if we're going to talk about the Fibonacci sequence and the ratio.
I don't ever talk about those in any of my math classes.
Okay.
All right, page 255. Many corporations, social clubs, and school classes that elect officers begin the election process by selecting and nominating committee. The responsibility of the nominating committee is to present the best qualified nominees for the office. Mr. Darnell's class of 10 students is electing class officers. He plans to start the process by selecting a nominating committee of 4 students from the class. Recall that in math, collections of items, or in this case, students, chosen without regard to order are called combinations. So if I pick 4 of you to go to Learning Lab, does it matter what order I pick the 4? No. If I say I'm giving extra credit, the first person gets 10 points and 9, 8, 7, then it matters at which number I pick you. Have we learned those words before in math, combination and permutation? No? Okay. So this is the first time you're hearing this. I would circle this word, combination, and write out to the side, order doesn't matter. Combination. Order doesn't matter. So if I pick 8 of you and we're going on a field trip, it doesn't matter what order I pick the 8 of you, we're all getting on the bus and going. Permutation, which isn't really a part of this lesson, but it's closely tied to this. So write this off to the side. Permutation. Order matters. So I'm picking a president. I got a grab bag and I'm picking a president out, a vice president, and a treasurer. It matters what order I pick your name out because that will determine what job you have. That'd be a permutation. Whenever we talk about this, we usually talk about your combination locks that are outside. Those are incorrect. When you type in your combination, does the order in which you do the numbers matter? It does. It's technically a permutation lock, but they've just never been referred to as that. So don't let that confuse you. Those are incorrect. Order matters. That's called a permutation. So Mr. Darnell has 10 kids and he wants to select 4 of them, or there's 10 in the selection that he's going to select from. So after the word combinations, it says the number of combinations of n distinct things taken r at a time is denoted by NCR. So it's actually pretty easy. If you read number 1, use the notation above to write an expression for the number of different combinations of 4 student nominating committees that Mr. Darnell could choose out of 10 students. So we have n distinct things taken r at a time. How many does he have and how many does he want to select at a time? He has 10 students and he wants to select or choose 4. That's it. How many you're picking from and how many you're going to select. That's just sort of the notation that we write it in. We say 10, choose 4. This will actually tell you if you figure out what this is. I will show you how to do it on a calculator. I will show you here in your book how to do it by hand. This will tell you how many different ways Mr. Darnell can pick 4 people from his group of 10. So the formula for the number of combinations of n distinct things taken r at a time is written in with factorial notation. Have we seen factorial before? The exclamation point, it's a very easy concept. So if I say 15 factorial, that means 15 times 14 times 13 times 12, all the way to times 1. Don't hit times 0, because then they would all be 0. So it's 15 times 14 times 13 times 12, down to times 1. If you ever see an exclamation in math that's read factorial, and the way you calculate it is definitely using a calculator like that. So if I want to know, I have 10 people and I want to pick 4, how many different groups could be made? This is how you're going to do that. If I have 10, choose 4. Let's just follow the formula. N factorial. N is the first number. So 10 factorial over R factorial. So that's 4. parentheses, n minus r, so 10 minus 4 factorial. So if I were to simplify that, that'd be 10 factorial over 4 factorial, 6 factorial. Now, you are not always going to write this out, but I want to show you something. 10 factorial, I will write out. And I'll write out this also, 4 factorial times 6 factorial. I wrote it out so you could see exactly what's happening, and it saves you some time. If all of this is multiplying, you see how you're going to save some time? 6 times 5 times 4 times 3 times 2 times 1 on the top cancels with 6 times 5 times 4 times 3 times 2. 5. So I have a whole lot less to type in. So go ahead with your calculator, take 10 times 9 times 8 times 7. I get 5040. And on the bottom, we don't have to type everything because we've already got some stuff that cancels. You just have to take 4 times 3 times 2 times 1. So we have almost 10 people in this class. We have 11 here today. And we usually have 4 for a group test. So this is saying if I had 10 of you, if one more of you was gone, and I was going to get 4 of you together to take a group test, I could make 210 different groups. They might not be very different. It might be these 4 as a group or these 3 with him as one group. So similar, but not exactly the same. It could be 210 completely different groups. Questions on doing factorial by hand. I'm not going to make you do it that way. Let's try it with our calculator and the factorial button. So type 10, hit math, and then go over to PRB. Does anybody know what PRB stands for? Probability. Math. Over to math. Over to PRB. And the 4th one down is factorial. Hit enter. Don't hit enter again because that's just going to do the top. You can. So my calculator right now says 10 factorial. Then hit divide by. I would put the bottom in parentheses just always to be safe. Type 4. Math. Over to probability. Factorial. And then we have to do times 6 factorial. You should get 210. Yeah.
Why do we need that?
You don't, it's just when there's multiple things on top or bottom, it's a good habit to get into. Because students don't know when to use them and when not to, so I say always. If we had not 10, but we actually have 11 students. If I wanted 11 students into a group of 4, would I have more combinations or less? What do you think, Jillian? More. Yeah, so you could just change this to 11 people and it would change your whole formula. So how does this relate? We're not quite sure yet. Let's look at number 3. An alternative notation for the number of combinations of n distinct things taken r at a time is nr with parentheses. So this is the same as this. So we did 10 choose 4. If you wrote that as 10 4, that would be the same notation. I don't know why they picked several ways to write it. But this is the same thing as that. Top number is how many things you have. Bottom number is how many things you're going to put in a small group. Let's see if we can type this in our calculator, which is the same as this. Please type a 10. Go to math again. Over to probability. Look down at your third option. Exactly the notation we've been talking about. Hit that button. It will say NCR and then hit your 4 to get 210. Question? Your eyes got big like, that's awesome, or I'm totally confused. That was awesome?
Is NPR for permutation?
Yes, it is. So if I did this, 15, 2, how would we type that in? Well, that's the same as 15, choose 2. Let's type that in our calculator. 15, math, over to probability. Hit that third choice, NCR 2. 105 different ways you could pick 2 people out of a group of 15. Any questions on combinations or either of these notations? You're going to start to see the connection when we get to the end of this second page here. Let's look at number 4. Find the value of each NCR shown and place them in a triangular pattern similar to the one shown. So when it says 0 above 0, that's saying 0, choose 0. You could type that in your calculator. Let's do that. I have 0 people. I want to choose 0 of them. I can only do that in one way. Don't choose any of them. So that is 1. Now don't type, do you guys know you can just hit second enter and it will pop it right back up again? Hit second, enter, and you don't have to go find that key again, just arrow over. We would now like to do 1, choose 0. That is 1. Hit second enter again. Now we're doing 1, choose 1. Just keep hitting second enter and type these in. Write your answers in the tree way that they're shown below. This is significant to our bell work. This is called Pascal's triangle. It doesn't stop here. It could go on infinitely. You could just keep adding 5, choose 0, 6, choose 0, and so on. Put this triangle side by side with your bell work and see what you notice. Brayden, you notice anything? Putting this Pascal's triangle next to your bell work and seeing if you notice anything. Jillian? That's true. Do these numbers appear on your bell work? 14641. I don't think all of you saw it. Look again. Look at your bell work. See if you find the numbers 14641. 14641. What was the row above that? That was 1331. 1331. And the row above that, 121. These are your coefficients for your binomial expansion. That's how all this combination stuff ties in. The combinations is sort of a statistic or probability term for order doesn't matter. But when you do these, it gives you a list of coefficients, and they will always correspond to your coefficients in your binomial expansion. Let's try a new one. Let's try on your scratch paper, a plus b to the 7th. We'll do this one and hopefully one more, and then we will understand it after that. On our scratch paper, because it's going to be kind of lengthy. We are not going to expand it out 7 times. That's going to take too much time. Allie, notice that if this is 7, how many terms am I going to have? Yeah. Yep. So this was to the 2nd, it had 3 terms. This was to the 3rd, it had 4 terms. So if we're doing to the 7th power, it's going to have 8 terms. We need to find our coefficients like we did with the triangle 1, 4, 6, 4, 1. How did we get those? We did this. So we're going to do, if we're down at 7, we need to do 7, choose 0, 7, choose 1, 7, choose 2. Go ahead and make a 7th row. It doesn't have to be in your notes. It could be on the scratch paper. We need to find those coefficients. Do you notice other patterns with your Pascal's triangle, how they go up and then back down? That's always going to happen too. Sometimes there's a repeated one, like 3, 3, and the number in the middle, there's no number in the middle. Those are just the same, like here, 35, 35. Sometimes it goes up to a number and then right back down, and this number in the middle is different. But once you notice it's going up and then back down, once I hit 35 again, I knew without typing it in, it was going to be 21, 7, 1. So you don't have to type in all of these. Once you get to the highest number you've gotten to, and it starts to go back down, it will just repeat on the way down. Any questions on how to get these coefficients? Yes?
Why are we plugging them into a calculator when it's just the adding of the branches above it?
Because we didn't have the branch above it. I'm at 7. I didn't have the 6th one.
But you can still find it by going.
But if I go to the 12th, I'm not going to want to do that.
Okay.
All right, so on your scratch paper, list out these coefficients, but space them out. So 1, 7, 21, 35, 35, 21. I did not do a good job. I try to fit it in one row, but if you have to do two, I guess that's fine. I like to put a plus sign in between each one. So do that. Will it ever turn out to be minus? Yeah, and we can fix that later. If this says A plus B, it's going to be plus every time. We can do a -1 next, and we'll see how that affects it. Let's go back to your bell work. There's basically three things you have to do. You have to do the coefficients, which we just figured out, and you have to do both variables. So let's look at A. Remember, it was A to the fourth, A to the third, A to the second, A to the first, A to the 0. So that's what we need to do. This one's going to be A to the what? Yell it out. A to the 7th. This is going to be A to the 6th, A to the 5th, and on down. Go ahead and fill that in. I usually don't write A to the first. I just write A, but you could write to the first power. I hardly ever write A to the 0 because I know anything to the 0 power is 1, but if it helps you, write that down. So I do my coefficients first using Pascal's triangle or your calculator. 7 choose 0, 7 choose 1, etc. Then I need to do this variable. If you look back at your bell work, the second variable is B to the third, B to the second, B to the first, on down the other direction. So I'm going to start down here, and I'm going to do B to the 7th, B to the 6th, and so on. That's your answer. If you multiply that out, A plus B, A plus B, A plus B, A plus B, multiply it out 7 times, it would simplify to that. Mine's a little messy, but fairly neat. So you could leave your answer if it's neat enough like that. So 1, or A to the 7th plus 7, A to the 6th, B to the 1st, plus 21, A to the 5th, B to the 2nd. It takes a long time to read the answer. But there's basically 3 steps. Your coefficients. We're pretty good with figuring out the coefficients. Does that part make sense? Then we do step 2, this to the 7th power on down. Then I do B to the 7th power going the other direction. Alrighty, let's try another one. I would do everything for the rest of the day on your scratch paper. We're kind of done with your book. Let's do 3A minus 4B to the 4th. Let me change that. I don't want 2 4s in there. Let's do minus 5B to the 4th. We're going to first do the coefficients. So these are in Pascal's triangle, but if they weren't, you would do 4 choose 0, 4 choose 1, until you got all your coefficients. We know they're always going to start and end with 1. Do we always know the second term? It's going to be that number. You might just have to type in the other ones. So my coefficients are 1, 4, 6, 4, 1. Let's put a plus in front of each one. No changes with the coefficients, even though this problem is a little more complicated. I need to do this, not just a. I need to do 3a to the fourth power, 3a to the third power, 3a to the second power. So it's no longer just an a, it's 3a to the fourth, 3a to the third. Go ahead and write that down. Before it was just a, so a to the fourth, a to the third. Whatever term is there, write all of it in parentheses. Okay, now we're going to write all of this with the minus sign going the opposite direction. Questions on this so far? Is this something you could do on your own right now? Given the calculator? Most yeses. Do we have a question? All right, we have 5 things we need to simplify. Every time you see a plus sign, we have a new thing to simplify. So let's start with this first one. Let's simplify this. 1, well, that's easy. Do we know 3 to the 4th? If not, type it in, please. 3 to the 4th power. I don't know it. I could figure it out. 3 times 3. 81. Okay, so this is 81, a to the 4th. We're done with that term. Let's go to this term here. Maybe I want to simplify this up above before I write it below, because the 4 is just a normal 4. Minus 5b is pretty easy. But let's simplify this. This is 3a squared. 3 squared is 9. So let's write this is 9a squared. Look at your coefficients. You have 4 times 9 times negative 5. Let's type that in your calculator. 4 times 9 times negative 5. Negative 180. And do your variables. You had a squared and b. Wait a second. This should just 4th, 3rd, 2nd. Did something get erased here? Hold on a second. This should say 3. That should say 2. This little squared. 5. Erase this. This needs to be a 3rd power. Hopefully that's what you had. This was 4th power, so this is 3rd power, 2nd, 1st. Now we're good. So let's fix this term. Simplifying this, what is 3 to the 3rd? Do we know that one? 27. Sorry about that. Now type your coefficients, which are 4 times 27 times negative 5. I got negative 540. My variables are a to the third and b. I'm working on this one here. 6 is just 6, so there's nothing that needs to be simplified there. If I simplify this green part, 3a squared is 9a squared. Simplify what's in blue. Negative 5b, quantity squared. Negative 5 times negative 5 is positive 25b squared. All of these are being multiplied, so let's do your coefficients. 6 times 9 times 25. And your variables, a squared and b squared. So I just like to simplify above. So the 4 doesn't simplify, the 3a doesn't simplify, but negative 5b all to the third simplifies, or can be rewritten as negative 125 b to the third. Once each term is simplified, let's multiply your coefficients. 4 times 3 times negative 125. Negative 1500 AB cubed. Last term only has one part, so take your negative 5 to the fourth power. So much more difficult. Same process. Notice your Pascal's triangle doesn't appear in your final answer, but it is important to write Pascal's triangle because you need those numbers. It's just more numbers appear because of these, and that takes those initial coefficients to be larger. Are we lost? How are we doing? Good, good. I've got 5 for you to try. We'll work on it more tomorrow. There's not much new tomorrow. I'm always here in advisory. If you want to pass to come see me and get some help, let me know. Three minus 5 equals